Hello pre-algebra students, this is our test 2 answer video. So past 2 nights of homework, you're about to watch the answers for the problems on that test review that you've done for 2 nights for homework. So let's start with balancing a checkbook. Excuse me. Alice Cool has a checking account with Citizens Bank. Her current balance on June 1st was $1,017.20. For the month of June, the following information was recorded on her check register. What is her ending checkbook balance on June 30th? So I'll tell you first the answer that I got, and then we'll go through and talk about how you get that answer. The answer ends up being $1,572.87. If you had no trouble figuring out how to do that, you can fast forward until you see me start writing in green for the next question. If you're not sure, go ahead and listen. Let's take a look here. Let's put reds on anything that's going to be subtracted, and we'll put green on anything that's going to be added. Okay, we're going to subtract checks, so red, 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 and we're going to add deposits. There really isn't a whole lot more besides that. Okay, so really is a question of taking your time one step at a time to subtract, add, subtract, add until you get an answer. And always do everything you do on the calculator 2 times. That way you'll be able to tell if you fat fingered it. All right, do the calculator work twice. Okay. Excuse me again. All right, next question. Oh, apparently I can't move that way. Just kidding. Here, there we go. Okay. We're going to write these in order from greatest to least. So the first thing I'm going to do is change each one to a decimal. So let's zoom in a little bit. Ooh, sorry, didn't mean to wobble it on you. So let's change first our percent to a decimal. Remember, it's 2 spaces back to change it to a decimal. 7/4 we're going to divide. That comes out to 1.375. And then 1.87 is already a decimal. 324%. Remember, a percent that's bigger than 100 is really just more than 1, so 3.24. And then this one, scientific notation. So now we're adding scientific notation into the mix. 0.035. So now that I know what the order is, let's make our decimal point good there. Now I know what their values are as decimals. Now I can put them in order from greatest to least. So I'm going to write that on top. Okay, so the 324% is clearly the biggest right here. 324%. So 324% is first. And then as I look through the numbers, it looks to me like next one down we're going to have is 1.87. And then the 7/4, and now we're down to numbers that are less than 1. So we have our 15.3%, because 0.1 is definitely larger than 0.03. So finally we have 3.5 times 10 to the -2 power. Sorry about that. A little bit of a mess problem there. Must be something on my iPad screen. Okay, next one. I'm going to switch to purple so you can tell the difference between the problems. This time we've got 0.86 for this decimal, 0.8 repeating for this one, and then this is an interesting one, 0 power. That means we're not moving the decimal point at all. So 8.0 times 10 to the 0 power is the same thing as 8.0. And again, we're going from greatest to least. Well, 8.5 is going to be the largest here. So we're going to start with that one. So 8.5 is my largest number. Okay, 8.0 times 10 to the 0 is my next number because that's equal to 8. And now we're looking at the numbers that are smaller than 1. So 0.8 repeating, which is 8/9, is going to be the next one, the repeating decimal there. 0.88, 88/100, and finally 86%. Okay, and then the last one. Let's use orange. 0.25 we have here for the fraction. 260% is 2.6, and then 0.26, and then 0.2 repeating. So this time the only one that's bigger than 1 is the 260%, so that goes first. Followed by 0.26, 26 hundredths, because that decimal is larger, 0.26 right here is larger than 0.25, and definitely larger than 0.2 repeating. So 0.25 is next, so 1/4, and then the last one would be your 0.2 repeating. Okay. I think we're at the point where we understand that pretty well, just a question of making sure we change them all to decimals successfully. Okay. Let's work on some practice with fraction operations. So the first one is addition. We're adding 6 1/2 plus 4 3/5. So first thing I'm going to think about is a common denominator, which in this case is going to be 10. So I have 6 and so many tenths plus 4 and so many tenths. We're multiplying by 5 here to get my numerator renamed. We're multiplying by 2 there. So that means that I can now add my whole numbers, add my fractions. So now I've got a rename because I've got half mixed number, half improper. 11 over 10 is the same as 1 and 1/10, so 11 and 1/10. Color change, okay. 4 1/2 times 1 2/5. Well, the first thing I know is I have to change these to improper fractions. So 8 and 1 is 9 halves. 5 and 2 is 7/5. Nothing I can simplify. No common factors diagonally. 63 over 10, which is 6 3/10. Awesome. Now, I know that these are daunting. I want you to remember that the operations with rational numbers, you want to look for the positives and negatives. You'll have something to use to study after class on Friday, or something to use to practice after class on Friday. So let's go with, let's see, negative. So this is minus a negative. So the first thing I want to do is recognize that I'm going to be adding here. And I'm also going to recognize that I'm adding two opposite sign numbers. So I'm going to have to use integer rules for this. So negative 6 3/4 is negative 6 and how many twelfths? That's 9, because we'd multiply the 4 by 3. And on this, plus 1 and 4/12. So, so if I'm adding these two numbers and I have the negative here, what I'm really going to do, because I can't actually add those directly, and I know that I can switch it around and make it 6 and 9/12 minus 1 and 4/12, and then just make my answer negative there. So let's do that. 6 minus 1 is 5, and 9 minus 4 is 5. So we subtract in the opposite direction using their absolute values, and then we make our answer negative. And then the last one we have here is division. Color switch. So negative 2 and 2/5, we have to improper these. So let's do that. Negative 2 and 2/5 is negative 12/5. Still division, don't change anything yet. Positive 1 and 1/3 is 4/3. Now keep switch flip. And now simplify. So both of these can be divided by 4, leaving a 1, leaving a 3. 3 times 3 is 9, and it's negative times positive, so negative 9/5. 5 goes into 9 one time with 4 left over. So negative 1 and 4/5. Continuing to the other side. So, bummer, had to actually go back and re-record this entire slide because the audio failed on it. Glad I checked before I just compiled the video. So, okay. So, oops, excuse you, cell phone, telling me I have email at very late at night. Okay. So, anyway, sorry. Okay, so now we're on to fraction word problems. We have a question about Dora and her cupcakes. It says Dora bought 48 cupcakes. 3/8 were vanilla. How many cupcakes were not vanilla? Not vanilla. So the first thing I like to do with a question like this is think, well, if I have one whole dozen and I take out 3/8 that are vanilla, how many are not vanilla? 5 of those eighths. So I need to find 5/8 of 48. And we've learned that that's multiplying. So simplify, multiply 30 cupcakes. Shane is a long-distance runner. He can run 6 4/5 a mile in 6 4/5 minutes. How many miles can Shane run in 30 minutes if he keeps up this pace? So this is asking how many times 6 4/5 can fit into 30 which says division. So we're doing 30 divided by 6 4/5. That's 30 over 1 divided by, multiply, add 34/5. That's 30 over 1 times 5 over 34. So now I'm going to simplify. Let's make sure my dot is clear there. Divide both these by 2. Multiply across the top and the bottom. 17. For a second there I got a little confused. Haha. That's 4 and, so 4 is 60. 4 times 17 is 68. So if you count up, that's 7 17ths left over. So Shane can go almost, let's see, almost 4.5 times, 4.5 miles. Okay, scientific notation, and that'll be it. So next one, changing 23,400,000 into scientific notation. Let's try to make that straight. Yeah, there we go. Close as I'm going to get it. Okay. So from the left, first non-zero digit is the first digit, so 2.34 times 10 to the 367. So counting 1, 2, 3, 4, 5, 6, 7. That's the same thing as saying 2.34 times 10 million. And it makes it so much easier to do calculations on a calculator when you can use scientific notation. Okay, first non-zero digit on this one is going to be the 2 also, so 2.27 for the decimal portion for this one. I already recognize that my exponent's negative, so I'm going to go ahead and write the negative sign so I don't forget it. And I'm going to count 1, 2, 3, 4, 5, 6, 7. So negative 7. Double check that. 1, 2, 4, 5, 6, and 7. So 6 zeros and a 2 for 7 decimal places. Okay, just keep practicing with that scientific notation. It'll get easier. 4.72 times 10 to the negative 9. Okay, so this time we're switching a number that's already in scientific notation back to standard. So write your decimal portion and move your decimal point. A negative 9 exponent says that this number is smaller than 1. So I'm moving my decimal point to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be a decimal point and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Why is it 8 and not 9? Because the 4 takes one of those decimal places. Okay, last one. 2.901 times 10 to the 6th power. We are taking, I don't know why I wrote the whole thing. I just want to write the decimal. 2.901 times 10 to the 6th power. So 1, 2, 3, 4, 5, 6. Moving the decimal point to the right and not the left because my number is bigger than 1. So this is 2,901,000. All right, so that concludes all the work. But real quick before I leave this slide, I want to remind you of the IXL skills that are here. And they're also on the first page. So let's go back to the first page. Here's the first page again. Here's the first page again. And I want you to, again, see the IXL skills. IXL skills, IXL skills. If you'd rather have Khan Academy, email me. Tell me which concepts you want skills for on Khan Academy, and I will find them for you. See you guys for your test on Monday. Have a great weekend.